So this is the Leaving Cert Ordinary Level 2023, Paper 1, Question 3. Solve the following equation in x an element of r. Now, an element of r just means that students often get caught up in this notation. So here it says an element of r. An element of r just literally means that it's a real number, and real numbers, positive and negative whole numbers, including zero, and they also include fractions and decimals. Okay, so real numbers are basically including all numbers. We can start off there just by writing out the equation that's given. So we can see that there on the first line. The next thing we need to do is we need to expand what we have here. So you can see we have 3 bracket 2x plus 4 minus 5 is equal to 3. And you can see there that multiplication only occurs with these brackets here. Okay, so we need to expand 3 times 2x. So 3 times 2x will give us 6x. And 3 times plus 4, 3 times 4 will give us 12. Okay, the minus 5 stays as it is, the equal stays as it is, and the 3 stays as it is. The next line then is just tidy up what we have. So you can see here we have a plus 12 and we have a negative 5. If we were to add 12, take away 5, we'd be left with 7. Okay. Now, in this question, it says to solve for a value for x. So basically what we need there is we need all the x's on the left-hand side, and we need that equals to a number. So we're now on line 3. You can see we've got x's, numbers, equals, numbers. If we're looking for a value for x, we need all the x's on the left-hand side, equals, and we need the numbers on the right-hand side. So let's bring that positive 7 there. If we want to get rid of that, we need to subtract 7 from the left-hand side. So if we subtract 7 from the left-hand side, we'll be left with just 6x. But we have to make sure if we subtract 7 from the left-hand side, we have to do the same to the right-hand side because it's an equation. We have to make sure that we have an equation that we keep balanced. So because we subtract 7 from the left, we have to make sure we subtract 7 from the right. That brings us to line 4. And you can see we've got 6x is equal to 3 minus 7. Again, similar to that, we can collect like terms. And you can see there we've got numbers and numbers. So we've got 3 take away 7. So 6x is still 6x is equal to 3 take away 7. 3 take away 7 gives us negative 4. Okay, and we're almost there. So the second last step is we've got 6x is equal to negative 4. We don't want 6x. We want to solve for x. So that means we want the value for x. So we want the value for 1x. Okay, so the hidden operation here, this here represents 6 times x. Okay, anytime we want to isolate a term, we need to do the inverse operation. So the inverse to 6 times is going to be the opposite times, and the opposite times is going to be divide. So we're going to have to divide by 6. So you can see here, if we want 1x, we're going to have to divide the left-hand side by 6 to get 1x. But because we divide the left-hand side by 6, we have to do the exact same to the right-hand side and divide the right-hand side by 6. So negative 4 divided by 6 is negative 4 over 6. We should know, well, you could always type it into your calculator, but at the same time, we should be able to identify the fact that 4 and 6 are both multiples of 2. So 2 is a factor, so we can divide 4 by 2 to get 2. And we can divide 6 by 2 to get 3. And obviously the negative stays where it is. So if we were to scale this fraction down, we could divide the top and the bottom by 2. And negative 4 over 6 will turn into negative 2 over 3. So that's part A. Part B. It says graph each of these inequalities on the number line. Note that x comes from a different set of numbers in each case. So B part 1 says x is less than or equal to 2.8. Now, when you're dealing with inequalities, always think of the crocodile. The crocodile always eats the bigger number. So in this case, we're saying that x is going to be less than or equal to 2.8. So if you think about that, it says that x is going to be an element of r, so that means it's going to be a real number. And we know already from what we did earlier that a real number includes everything. Positive and negative whole numbers including 0, and it also includes decimals and fractions. So 2.8, if this is 3, if this is 2, 2.8 is going to be somewhat closer to 3, so it's going to be somewhere around here. Because it includes every number, it includes the positive whole numbers, it includes 2, it includes 1, it includes 0, it includes the negative numbers minus 1, minus 2, minus 3. It also includes the decimals, so it includes 1.5, it includes 0.5, it includes 0 or negative 0.5, negative 1.5, negative 1.8 or 2.8, which would be somewhere around here, negative 2.2, negative 2 or 1.2, negative 1.1, negative 1.9, negative 1.7, negative 1.5, and so on. So because it includes all these numbers here, what we can do is we can go to 2.8, 2.8, and we can draw a solid line going the whole way back, and it includes everything. So every number along those lines represent x. So in other words, if we had 0.2, 0.2 would satisfy a value for x. 1.4 would satisfy a value for x, and so on. For part 2, it said x was less than or equal to 2.8 again. So we still have our 2.8, but this time they're saying that x is going to be an integer. So z represents our integers, and our integers are positive and negative whole numbers, including 0. So that's something that people often overlook. Positive and negative whole numbers are your integers, but you have to include the fact that it includes 0. So positive numbers less than 2.8 are 2 and 1. We have to include 0, and we have to include our negative numbers, and our negative numbers there are going to be negative 1, negative 2, negative 3, and negative 4. So integers are positive and negative whole numbers, including 0. The last part of that question was part 3, and it said x was less than or equal to 2.8, and this time x was a natural number. Now you should know natural numbers because they're the numbers that you first dealt with when you first came into secondary school. They are your positive whole numbers, often referred to as your counting numbers. So they're your positive whole numbers. So any number that is greater than 0 and is less than 2.8. So we know 2.8 is going to be somewhere around here. This number is going to be a natural number less than 2.8. So 2 is obviously going to be the nearest whole number. 1 will be the next one that's less than 2.8. And we can't include 0. So integers include 0, whereas natural numbers don't include 0. They're just your positive whole numbers greater than 0. So that brings us to part C. Part C says use algebra to solve the following simultaneous equation. So we know by looking at it that we have a simultaneous equation because we've got x's and y's and x's and y's. So we've two equations with two unknowns, and the unknowns in this case being x's and y's. When you're dealing with simultaneous equations, what we like to do is we like to keep the x's and the y's on one side and the numbers on the other. So in this case, we're dealing with x's and y's. Sometimes we might be dealing with a's and b's or some different variation. So typically keep your x's first, your y's second, your equals on top of each other, and your numbers to the far side. When we look at this, we know we've got x's and y's, so we need to get rid of either the x's or the y's. In this case, I decided to get rid of the x's, and I did that by scaling up my x's. If I wanted to get rid of my x's, I'd need to have a 2x and a negative 2x on top of each other, because when I add the equations, the x's will cancel. You could have got y's on top of y's by multiplying the top equation by 4. That way you would have had y's on top of y's, you'd end up with the same answer. In this case, I'm just going to go get rid of my x's. So, in order to get rid of the x's, I had to have a 2x and a minus 2x. The only way I could have that is if I multiplied the top equation by negative 2 or negative 2. If I multiplied the top equation by negative 2, I'd get negative 2x. A minus y by a minus 2 gives me a minus by a minus, giving me a plus. And a plus 1 times 2 gives me a 2y. Similarly, I have my equal sign and my equal sign. A negative 1 times a negative 2 is a minus by a minus, giving me a plus. And a 1 times 2 giving me a 2. My second equation stays the same, so I just write that back in here as it is. And you can see from that, if I was to add my two equations, my x's would be gone. So 2x take away 2x leaves me with nothing. Because I'm adding these equations, I can say that 2y plus 4y gives me 6y. Similarly, 2 plus 19 gives me 21. I'm looking for a value for my y's and a value for my x's. In this case, it's easy to get a value for my y's because here I'm saying 6 times y gives me 21. So in order to be able to solve for y, I need to be able to find out what 1y is equal to. If I want to go from 6y to 1y, I need to look at the operation that's happening here. Here I'm saying 6 times y. The opposite times by 6 is divide by 6. So if I divide this here by 6, I'll get 1y. Because I divide the left hand side by 6, I have to do the exact same to the right hand side and divide 21 by 6. You may notice there that here we have a common factor, which is 3. 3 goes into 21 7 times and 3 goes into 6 2 times. If you had typed 21 over 6 into your calculator, you would have got 7 over 2. So far, we're after finding the value for our y's. This is a simultaneous equation. That means we need to get a value for our x's and a value for our y's. So we can go back there and find the value for our x's. So we found x, now go back and find y. We take an equation, we can take the first equation or we can take the second equation. I always find it's easier just to take the first equation. So take the first equation, write it out, the exact same as it was. And this time we have a value for our y. So because we know a value for our y, we can sub in a value for our y. Our x value is going to stay as x. Our y value is going to change and we're going to put in 7 over 2. We now need to solve this equation. So if we were looking at this line here, how we move from this line to the next line is we keep all our x's on the left hand side. So we're going to keep this x here. Instead of subtracting 7 over 2, I'm going to do the opposite. I'm going to add 7 over 2 to the left hand side. If I add 7 over 2 to the left hand side, that leaves me with just x because minus 7 over 2 will cancel with positive 7 over 2. Because I've added 7 over 2 to the left hand side, I have to do the exact same to the right hand side and I have to add 7 over 2 to this side. And you can see there in this step, I've taken my negative 1 and I've added 7 over 2. The last step there is just to tidy this up. And you can see if I have negative 1 and I add 7 over 2, that leaves me with 5 over 2. Now, if you are unsure of your numbers, you could always type that into the calculator and negative 1 plus 7 over 2 will leave you with 5 over 2. So you had your simultaneous equation, you found the value for your x, you found the value for your y. You can always go back and check your answer. If you had an x value of 5 over 2, and if you subtracted a y value of 7 over 2, that would leave you with negative 2 over 2, and negative 2 over 2 is the exact same as having negative 1. So that's the end of question number 3.